I think the most important thing is doing something which is not only going to make money, but is also going to be ethically correct and which is making a contribution somewhere along the way. In the old days when we started, you made cell therapy from your own cells, had to be changed, treated and returned to your own body. A very costly and expensive process. What we're doing now is we're making an off-the-shelf cell therapy, which will make cell therapy accessible for everyone. So I think that's an impact, a societal impact that we're having with this technology. When we used to be working on retroviral vectors, we were trying to change viruses and change them from being a bad thing for people to a good thing, to make them a vehicle that you could use to transfer genes. And in order to use that as a treatment for human diseases, you need to be able to get a lot of virus into people. So we were thinking about how can we increase the number of viruses in a person at one time, and the idea came up to encapsulate the cells producing the virus and implant them into the patient so they would be producing virus over a long period. So we developed that further and we decided to work on a new type of cellulose which was modified and improved, that we could use it inside the body, and of course that we could then grow all sorts of cells. And then the biggest issue that we have with using living cells is that living cells are incredibly fragile. So they're being beaten by the environment, they're being beaten by the immune system, everything is going against the cell. So we're trying to protect the cell so it can survive for long periods and can do what it's supposed to do, which is hopefully making something good for the patient or for the environment or for the situation that the cell is in.
We use a natural polymer, which is cellulose, which is basically plant-derived material, so it's easily to source. It's a sustainable source. It can be made from waste products, from wood waste products, from sugarcane waste products. And we chemically modify that, and then we make a solution mixed with our cells, form droplets, and the droplets form in a bath which harden from outside in. So the cells or the bacteria are entrapped within the bead, and then they are protected within that bead.
And that gives us a very reproducibly filled, high density filled capsule, which is not achievable with other technologies.
I think also we've solved plenty of the issues of GMP production. So we have our GMP production facility in Thailand, and that is also quite a tall order because you have to have reproducible capsules every time you do a run, and that is not so easy to achieve. I'd just like to add that Japan is a very important market for us, of course, partly because Japan is a world leader both in stem cells, cell therapies and in probiotics. So it's very important that we make partnerships and have clients and partners in Japan, and we feel very grateful that we've been working together with Realtek and with LevaNest to get into contact with Japanese companies.
The whole market is changing, so what you have to do is prepare to invest now, to jump on board the train now, so that you will be in a position to go off the final station and sell your product when the market is at that point, and at that time you will be the leader. So if we can find Japanese companies that share that vision to be the leader, to be ahead of the pack and really go ahead, I think they would be the best sort of partners for us moving forward.